safe enough distance for a year, and at night, it's even more. Now we venture to stars that exceed the sun's mass 1,000 times. Cepheid is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty, but it's still so big that it could hold a billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light years from home. Here it is, a red supergiant called VY Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It can fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the sun. In the context of celestial bodies, we call this star an inflated balloon. In the next 100,000 years, VY Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed NY Cepheid in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles long, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our sun. We need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand.
Yeah, I'm listening, yeah.
Wow, the great day is finally upon us. The record-breaking hole-boring team is finishing their job today. Spectators have gathered from all parts of the continent just to look at the greatest borehole in the world. And even the Guinness World Records Commission is officially dumbfounded. The hole is more than 1,000 miles in diameter and goes almost as deep as the Earth's core. No one achieved this depth before. But wait, what's going on? People all around suddenly begin fainting. More and more of the spectators fall unconscious on the ground, their faces white. Did the gas pocket? Oh no! We're getting messages from all over the world that people start falling just where they stood. What in the world is happening? So, this is the scenario you get if you dig a hole in the ground deep and wide enough to fit the whole atmosphere inside it. Let's explore. The atmosphere goes really high up, getting thinner and thinner the higher you rise. For example, on the ground level, you can breathe freely. Well, on top of Everest, you won't be able to survive for long if you haven't had a good training course beforehand. The air on the mountaintops is much thinner, and so it's a lot colder and harder to breathe there. If you rise even higher, say to the altitude where airplanes fly, you probably won't be able to breathe at all. That's because they have oxygen mass on board. If the plane loses its inner pressure, the air from the outside will rush in. And since it's too low in oxygen for your lungs, you're likely to lose consciousness very quickly. All that doesn't mean our atmosphere ends there. In fact, it goes far beyond. And some scientists say it could even include all the distance to the moon and even further. Oxygen molecules from the Earth's atmosphere can be found at massive distances. Although there are so few of them, you won't be able to use them anyway. and the furthest range the atmosphere goes is almost twice as far as the moon. But those are no more than tiny specks of hydrogen at that point. Now, if we somehow compress all this volume into a relatively small bubble around the planet, it would be about 6 miles above the ground, roughly the height at which commercial airplanes fly. Any higher, there's big cosmic nothing called vacuum, where no airplane would be able to navigate. Next step, fitting this massive air into a hole in the ground. For starters, the entire volume of our rather thin bubble is only enough to fit into a 1,000-mile cube. This is just a little smaller than the Earth's core, and a side of such cube is about a third of the United States east to west. And here's the first serious problem. No one has ever dug a hole that deep, or wide for that matter. The deepest human-made hole in the world is the Kola Super Deep Borehole, and it's only going about 7 miles down. The drilling stopped because of unexpectedly high temperatures. Drilling and digging, though, are different things. The Kola borehole is only 9 inches in diameter, while what we need is to take a supermassive chunk out of the Earth to fill it with air. Still, at about the same depth, we'll face the temperatures of around 350 degrees Fahrenheit, and the deeper we go, the hotter it'll get. The Earth's core lies at 1,800 miles, so to dig that cube, we'll need to go more than halfway to the center of the planet, where the temperature will reach almost that of the sun's surface. And that's not considering the time we'll need to dig that deep. Anyway, let's assume we have the equipment that can withstand such heat. As we go down, the air fills the pit and slowly leaves the atmosphere. And as it gets deeper, the pressure on it grows too, making it take less space. In the end, with all that weight from above, we won't even need such a deep hole, right? Nope. The high temperatures in the Earth's innards makes the air less condensed and compensate for the pressure. If the surrounding rock is hot enough, it will expand the air to such a degree where it will take the same amount of space as on the ground level. And when it gets even hotter than that, well, the air will actually take even more room than we've calculated. But that easily daunting. The experiment continues with an actual 1,000-mile cube dug in the Earth's surface, reaching into the crust and mantle and almost to the molten core. The air expands from the heat and starts taking up more space, resisting its imprisonment. That's why we begin digging to the sides at lower parts of our hole. To compensate for the air expansion, the additional hollows span over 4,000 miles. That's about the radius of the planet. Finally, the air seeps down, leaving the atmosphere and filling the internal parts of the Earth. And still, it won't stay put. Some of the air is yet on the surface, and everyone can still breathe, although it's becoming much harder. Turns out, to fill the pit with air, we'd need to dig so much that the Earth would just fall apart before we finish. But even now, the enormous hole we've made has changed the planet's center of mass, and is now spinning and revolving around the sun more slowly and awkwardly. Instead of pushing all the air from the atmosphere down below, we've caused a cataclysm that would destroy our planet much more quickly than the lack of breathing air. Okay, so let's rewind then. We can't dig a hole in the ground because the air just won't fill it, but stubbornly spills out, and eventually our planet will just be torn apart. And we probably can't dig through the ocean's bottom because the hole will get filled with water instead, and the air won't have the room either. And that's not saying anything about all the water that gushes down to the hot layers of the Earth, causing catastrophic reactions that will, you guessed it, blow the world to pieces. If so much cold water reaches the extremely heated depths of the planet, hot magma below will start releasing toxic gases into the atmosphere, suffocating any life on the surface. So, the only chance to fill the hole in the ground we made is to compress the air to a liquid state, almost like they do with scuba gear. The oxygen tanks are filled with super compressed air that allows divers to breathe for a long time using just a small vessel. Now, we could just fill several 100,000 of such tanks with compressed air from the atmosphere and throw them all into the hole we've dug. The pile will only be several 100 miles high, so technically it's not possible. Or we could invent a really, really huge tank for just this one purpose, pump all the air from the atmosphere in there, compress it as much as possible, and then dump it into the ground. Congrats! Mission accomplished! We've dug a hole deep and wide enough so that all the air around the Earth fits inside it. Now, what happens next is all life on the planet stops breathing. Humans, animals, plants, even aerobic microbes can't survive without oxygen. So everyone and everything is effectively wiped out. Then, no more oxygen means no ozone layer either. The lack of this natural barrier makes the planet extremely vulnerable to the sun's radiation and cosmic rays. The flares from the sun stop warming the Earth and begin scorching it instead. The surface of the planet rapidly becomes an arid wasteland, bombarded with heat and UV rays. Next goes tectonic activity. With the temperature outside spiking, volcanoes start erupting all around the world, making it a churning mass of hot lava. Oceans boil and evaporate, mixing with toxic fumes and creating a thick blanket of black cloud. Ash and acid fall from the sky, covering the already scarred Earth. And finally, our former blue and green planet turns into a twin sister of Venus, the unbearably hot and inhospitable place where no life is possible. Well, this would not be a smart thing to do. So please, let's not try this at home. You want a super big hole? Try the Grand Canyon. The space between galaxies and stars isn't entirely empty. It has several atoms per every 35 cubic feet of vacuum. In the visible universe, there can be up to 2 trillion galaxies. Gas giant Jupiter is the planet with the shortest day in the solar system, just 9 hours and 55 minutes. Because of its fast rotation, Jupiter isn't a perfect sphere. The planet is a bit flat. But even though a day on Jupiter is more than twice shorter than on Earth, the year on this planet lasts way longer, almost 12 Earth years. Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object. For example, an asteroid. Lots of black holes are surrounded by streams of dust and gas. They circle around the hole just like water moving down a drain. In the process, columns of matter that look like ginormous mountains rise straight into the air. Radio signals spacecraft send to Earth are so weak, they can hardly power a fridge light bulb. When these signals reach the surface of our planet, they get reduced to a mere 1 billion of 1 billion of 1 watt. What? That's why dish antennas that detect these tiny signals are gigantic. Some of them reach 230 feet in diameter. It's almost as tall as the Statue of Liberty. Black holes are known to spaghettify things. As soon as something goes past the point of no return, the black hole's gravitational pull starts to stretch this object in one direction and squeeze in another. This phenomenon is also called the noodle effect. So there's pasta in space now? Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowy surface. It looks blotted and resembles a pepperoni pizza. Not quite pasta. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day. But you'd have to wear a hat. At your head height, it would be freezing cold. You wouldn't be able to stand on Saturn. The second largest planet in the solar system is made up mostly of gases. Its colorful rings aren't solid too. They consist of dust, pieces of rock, and ice. Some of these bits are as tiny as grains of sand, others as huge as Earth's skyscrapers. Saturn rotates very fast. The planet needs a bit more than 10 hours and a half to spin on its axis. Scientists haven't figured out the exact time yet. But the year is super long. It takes the planet more than 29 Earth years to go around the sun. Europa, one of Jupiter's 4 biggest moons, is covered with ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches. So if you're into ice skating, you would like it there. A 3-foot axle jump on Europa would lift you 22 feet high, but the landing speed would be the same as on Earth.
A staggering 97% of all water on Earth is salted, and only less than 3% is fresh. More than 2% of this fresh water is frozen in glaciers and ice sheets. It means rivers, lakes, and underground reservoirs contain just 1% of our planet's fresh water. Mercury is the smallest planet in the solar system and the second densest. It consists mostly of rock and heavy metals. If you got there, your weight would be just 38% of your weight on Earth. If you lump together all the known asteroids in the solar system, their weight would still be smaller than 10% of the mass of our moon. There are not only dwarf planets, but also dwarf galaxies. They have from 100 million to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. Some astronomers think that black holes might have no event horizon, also called the point of no return. Instead, there might be the apparent horizon, which can only trap stuff for some time. Later, matter or energy escapes, but in a different form. The gravity on the surface of Mars is just 38% of that of Earth. It means you could probably jump almost 3 times higher on Mars than you can on Earth. Another place good for high ice skating axle jumps. Uranus may be the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision, but it's just a theory. And Uranus isn't talking. Earth has a strong magnetic field that protects the planet from solar winds. The field exists thanks to the Earth's fast rotation speed and its molten nickel-iron core. Cryovolcanoes on Pluto, sometimes informally called ice volcanoes, spit ice, or rather a melted mixture of water, ice, and frozen ammonia, nitrogen, and methane. Yeah, that's a popsicle you don't want to lick. Mars might get a set of rings on its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, its likely dense atmosphere, and most meteoroids break up after entering it. That's why those that manage to reach the planet's surface leave clusters of overlapping craters. Mercury has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. The winds on Neptune are likely to be the speediest in the solar system. They can move at 1,600 miles per hour, and Neptune's huge spinning storms are so big they can swallow the entire Earth. There are different kinds of galaxies up there. Astronomers have discovered spiral galaxies, elliptical galaxies, and irregular galaxies that need to find a bathroom all the time. There are also lenticular galaxies. That's a mix between elliptical and spiral ones. Scientists believe that spiral galaxies are younger than elliptical ones. As a spiral galaxy begins to run out of its gas and dust, the star formation in it slows down. That's when the galaxy starts to lose its spiral shape and slowly turns into an elliptical one. The largest known canyon in the solar system is Valles Marineris on Mars. Doesn't that sound like Martian pasta with red sauce? This canyon system is long enough to stretch from New York to California. It's also 4 times as deep and 9 times as long as the Grand Canyon on Earth. Dust storms on Mars are the largest and most severe in the whole solar system. It usually takes them just several hours to develop. After that, the storms envelop the entire planet and go for days or even months on end. Venus is sometimes called the Earth's sister planet because of their similar mass, size, and distance from the Sun. At the same time, Venus is very different from Earth in some other aspects. For example, its temperature is way higher, and the atmosphere is much denser. Scientists think that the moon's surface has more craters than Earth because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep remaking the surface of our planet. But the moon has almost no weather to change its appearance. Venus, the hottest planet in the solar system, heats up to the average temperature of almost 900 degrees Fahrenheit. That's hotter than a self-cleaning oven. Earth-grazing fireballs are bright meteors that enter the Earth's atmosphere but then leave it again.
No.
The largest planet in the solar system, Jupiter, also has a set of rings, but they're dark and almost impossible to see with the unaided eye. The rings are made up of tiny bits of dust and might have existed since Jupiter was formed. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator